This video is going to be on arithmetic sequences and partial sums. And if you remember from the last video, a partial sum is the same as, wow, I can't spell today. Partial sum is the same as a finite series. Okay, so an arithmetic sequence is basically a sequence whose terms are achieved by adding the same number every time. This number is called the common difference. So if I have A1, A2, A3, A4, and so on, all the way up to A sub n, and I keep going. The difference between the terms, so from A sub 1 to A sub 2, should be the same as from A sub 2 to A sub 3. So if I were to subtract A sub 1 from A sub 2, that's the same as if I were to subtract A sub 2 from A sub 3. And so on, continuing on, A sub 4 to A sub 3. And I would keep doing that until I get, you'll notice, they should all equal the same value, D. This D is called the common difference. Alright, so this common difference is just a number that I'm adding to the next term to get the previous term to get my next term. Now this common difference can be a positive number or it can be a negative number. It doesn't matter. The difference is, though, is I'm adding every time. Whatever that difference is I'm adding it. So, for example, let's say I have a sequence whose nth term is 4n plus 3. For the sequence here, my common difference between the consecutive terms is 4. So, my first term, if my n is 1, I do 4 times 1 plus 3, so that would give me 7. For my second term, I do 4 times 2 plus 3. 4 times 2 is 8, plus 3 is 11. And then I would get 15, and then I would have 19, and so on until I get to 4n plus 3. Okay, and this, remember, will go on forever. But you'll notice the difference between them, 11 minus 7 is 4. So you'll notice that 4, the common difference, is the same as the number that I multiply my term by first. So that's one quick way to start off by writing your nth term. Whatever you're multiplying, or whatever your common difference is, that's what you multiply by. I'll show you another example. Let's say I have 1/4 times n plus 3. Well, my first thing I would do is substitute 1 in. I would have 1 plus 3, which is 4. 1/4 of 4 is 1. For 2, I'd have 5/4. For 3, and my stylus does not like me. It just keeps messing up on me. For 3, I'd have 6/4, which reduces down to 3/2. For 4, I'd have 7/4. So you'll notice I'm going to be alternating between 4 and 2 on the bottom, and I'm going to be changing by odd numbers, it looks like, on the top, because I'll have 1/2, sorry, not 1/2, I'd have 2 is my next term, because that's 8 over 4, which is 2, and then I'd have 9 over 4, you know, and so on. So every other one is increasing by the next odd number on top, and then increasing, really it's increasing by 1/4 every time. My common difference is 1/4. So, because I have 4/4, then 5/4, then 6/4, then 7/4, 8/4, 9/4, and so on. So really, this is increasing by 1/4 every time. And again, that 1/4 that I multiply by is the common difference. So from there, once you figure out your common difference, you just have to figure out how to get your term from 1/4. So if I multiply 1 by 1/4, how do I get another whole? Well, I got to add 3/4 to 1/4. What is, do I add 3/4 every time? No. If I am in my second step, I get 5/4. So 5/4 times 1, or 2 times 1/4 is 1/2. How do I get to 5/4 and 1/2? Well, I got to add another 3/4 to that. So every time you'll notice, after you multiply by 1/4, you're going to have to add a 3/4 to it. And so that's how we would get our equation for that, our nth term. The next thing I want to bring up is what we call not arithmetic. So for example, the sequence 1, 4, 9, 16, and so on. These are all the terms that are squared. So n squared. This isn't adding or subtracting the same value every time. The difference between the first two terms, 4 minus 1, is 3. The difference between the second two terms, 9 minus 4, that's 5. Because they're different, this is not arithmetic. Okay? So if you have two different values for the common difference, this is not an arithmetic sequence. And it's quite obvious, you know, when you have n squared, that's multiplication, not addition. So, you know, that's obviously not going to be arithmetic. So the cool thing is these last two things I just showed you is this shows us that if I want to find the nth term of an arithmetic sequence, all I have to do is take my common difference and multiply it by whatever my step is that I'm on, whatever my term number is. So to find any nth term, a sub n, I take my common difference, multiply it by that n, and then I add some other number. Well, that other number ends up being the value of the first term in the sequence subtracted by the common difference itself. So that is a pattern that we have figured out in math, and that's pretty much all it really takes. There are also besides just finding the terms of an arithmetic sequence, we can also find the sum of those terms. And remember, this is what we call a series, sum of a finite arithmetic sequence. Again, this is another term for a partial sum. Okay, so a partial sum is, or a sum of a finite arithmetic sequence would be S sub n, capital S, sub n equal to n over 2 times a sub 1 plus a sub n. Now this is a very fun investigation if ever you want to do it. Basically, to figure it out, you take two of the same sequence, add them all together, but in reverse. This is actually what is commonly known as the backwards method in finding multiple sums. So like for example, let's say I want to find the sum from 1, from 1 to 19 of all the odd numbers. That's kind of a lot to do. So what we do is we would then do the same thing, but backwards. Let's see, I'm at 13. And you'll notice when I add all these together vertically, I get 20 every time. And so how many 20s do I have? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 20s. This is the same as 10 times 20. A lot faster to do that added together as opposed, or multiplied together, instead of adding all of them together. 10 times 20 is just 200. That's way faster than having to, and I can think about this in my head. Well, what's 1 and 19 together? Well, that's 20, and they all add up to 20, and how many numbers is that? Well, that's 10 times 20 is 200. Way quicker than having to add them all up together. So this is where we got this formula, this idea of adding the same thing twice. So that's why we have the 1/2 in there in the formula up here. We have the 1/2 times n, or n over 2. And then I just take the first term, that would be 1, and the last term, that would be 19, and add them together. Take the number of terms, or divide by 2, and that's what we get. So that's where we get the sum of a finite sequence, arithmetic sequence. This also works. There's a famous mathematician who was like really young in 4th grade. His teacher was annoyed with him because he was so bright. He just got through stuff so quickly. And she said, well, I know what will stop him and keep him busy for a long time. I want you to add all the numbers from 1 to 100. So he said, okay, I did 1 plus 2 plus 3 plus all the way until I get to 100, right? Well, if I do that twice, then I will have, and add those together, I will have 101 100 times. So 101 times 100, well, that's 100, or sorry, that's 10,100. But I did that twice, so I got to divide it in half. So that's 5,050. And the teacher came back. He came back in like 5 minutes, and she was dumbfounded that he had already found it. But he used this formula, S sub n equal to n over 2 times a sub 1 plus a sub n. That's that formula right there. And so you can do the same thing for yourself to help you find the partial sum of an arithmetic sequence from one term to another. Hope you enjoyed it.